Under the Mobil Serv offer, this video is a piece of the on-the-job training curriculum for a central grease system inspection. The goal is to enable you to convert customer needs and opportunities around these activities into improvements in safety, environmental impacts, and productivity. The video is the first part of the OJT curriculum. After viewing it, you should job shadow a competent person conducting an inspection. Then have the competent person observe and coach you as you complete an inspection. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. Brendan, a lube engineer for ExxonMobil, has been working with this existing customer on a number of Mobil planned engineering service projects. John, his contact at the mill, tells Brendan that he'd like them to focus on central grease system vulnerabilities and improvement opportunities. Both Brendan and John believe that a central grease system inspection can aid in understanding the root cause of some bearing reliability problems John has seen. Brendan works with John to understand the impacts of any lubrication problems so he can later use this information to show how his findings and recommendations can reduce these impacts and produce value for the customer. Central grease systems are frequently used in steel mills, paper machines, and mining mobile equipment to handle the harsh conditions. As you can see, lubricating these bearings next to hot rolling steel is best done by an automated central system, not manually. For some customers, Brendan performs routine central grease system inspections to proactively look for improvement opportunities or to detect abnormal operating conditions. In most cases, Brendan may conduct specific inspections to address a specific issue. To help bring solutions and value to his customer, Brendan must be an excellent detective and must collect the data needed to help determine the root cause of any central grease system problems. Before meeting John again for the inspection, Brendan gathers background information: equipment make, model, size, and age, maintenance history, lube system design and drawings, and lubrication consumption rates. Brendan also refers to OEM manuals for equipment layout, design parameters, and theoretical lubrication application rates and usage. He uses the Mobil Serv engineering calculator tool to consolidate and analyze the information he finds. Then, just before his site visit, Brendan goes over his safety preparations, like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also reads through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including personal protective equipment, PPE. He also takes a moment to refresh his awareness of these life-saving rules and how they may apply to his activities that day. He will isolate energized systems, protect himself against falls, and maintain visibility of key hazards. He prepares and reviews his toolkit, including Clipboard or tablet PC or iPad, Engineering Toolkit app and inspection worksheet, identification tags and chalk, flashlight, digital camera, and shop rags.
Hey, John.
Hey, Brendan. Good to see you.
Good to see you. How's it going this morning?
Good. You have to do the grease system survey today?
That's the plan, at least.
Excellent.
On the morning of the site visit, Brendan and John review their goals for the visit. Brendan goes over his safety plan, and together they review the personal protective equipment he'll need: hard hat, safety glasses, fire-resistant suit if required, hearing protection, gloves, and safety shoes.
And be aware of your surroundings at all times.
Brendan conducts his inspection on the central grease systems that lubricate the bearings that the mill has reliability issues with. Typically, he starts his inspection from the start of the grease supply, then continues his inspection all the way to the lubricant's endpoint, in this case the bearings. Brendan starts his inspection by checking the inlet air to the pneumatic grease pump. He wants to make sure the air compressor goes through its loading cycle with proper air pressures. Then he checks the grease lines coming in from the main supply tote, looking for leaks. At the control panel, he checks whether timer controls are set correctly and that the right pressure reads on gauges. He can manually fire the system and record system pressures at the lubricant pump and at the end of the line. This will help to determine any pressure loss or supply failures in the system. He looks at the distribution block, checking for leaks. Moving farther into the mill, Brendan inspects these injectors. The pin position shows that they have fired. He notices these absorption hangers in the grease lines. The rubber hangers allow some vibration without breaking. He records this as a good customer practice. Brendan discovers this leak from an injector block. That's fresh yellow grease, probably coming out of a blown-out rupture disc. Most likely, a plugged grease line from this injector caused the injector disc to rupture. Brendan records this injector and bearing so he can have the customer correct this. Then just to the right of that leak, you can see where older grease has fallen out of a bearing. The large pile indicates that this injector may be set too high in this case. Brendan will compare his theoretical calculations to the actual injector settings. If there is a great difference, he will provide recommendations for the customer to adjust them slowly over time. He spots this bearing for one of the rollers of hot steel. It too shows signs of excessive grease. Brendan moves on to another grease system of another section of the mill. This one is fed from a grease drum. He notes this might be a good application for a larger grease tote or bin in the future. He checks the air line in and the grease line out to make sure there are no leaks. He notes the state of cleanliness of the cover over the drum. At the bulk reservoir, Brendan checks the air pressure gauge below, also the level indicator on top. He then finds evidence of a leak where this hose fits into tubing. Brendan asks an operator to operate this dual-line grease system from a different control panel so he can observe how it responds and whether the system is in alarm. He soon discovers these over-greased bearings. So much fresh grease coming out is a fire and slip hazard, plus a waste of grease. He notices that this injector has been disconnected, probably because it became plugged. The mill is using a manual grease fitting as a temporary fix. Just below that, Brendan checks this injector block in this dual-line system. Brendan stops by the mill shop to inspect some chock bearings taken out of service. He sees contamination, but overall, the bearings are in pretty good condition. This injector block is pretty heavily covered in contamination and may impede injector operation. He makes note of this finding so the customer can ensure they are cleaned before being put back in operation. After his inspection, Brendan meets again with John to explain his preliminary findings.
Wanted to come back in, talk to you a little bit, share some of our findings. Found a couple areas where the grease lines weren't actually hooked up to the grease injectors.
Well, I'm glad you guys
Got
caught
a couple
that.
pictures out there on the BD mill.
Brendan tells John that he will combine his findings, including measurements and photos, to prepare an engineering service report for John and his supervisors. He must take in all the facts and sequence of events to determine potential root causes of any problems he finds. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce an excellent return on investment and value to his customer. In addition to helping this customer in this one application, Brendan will see how he can help the customer apply what he has learned to other similar situations. Brendan and his sales advisor can use this report to promote our value to other key contacts at this customer. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. By using the standard operating procedure as a guide, as well as the other tools described, Brendan can consistently conduct these services and deliver outstanding value to his customer.